طيب. Okay, to start with, inshallah, first I want to tell you about this announcement. If you are interested, so tonight at 7 p.m. I'm invited to give a talk to the كلية العلوم دراسات الإنسانية في جامعة الإمام عبد الرحمن بن فيصل. The talk titled Isolation Matrix Infrared Spectroscopy, a New Approach to Probe Molecular Structure. Here you have the Zoom ID. I think you just need the Zoom ID and the password. So the Zoom ID is, if you want to write it down, 942-1900-5075. The password, write it down if you wish to attend. Phys, P is capital letter, Phys, BHYS 319. You need those. It will be start, inshallah, at 7. I'll be giving the talk. And if you have time and you want to learn something new, something interesting, it's a mixture of physics and chemistry and optical and molecular physics. So if you would like to attend, it will be a nice thing for you, for your benefit. Bye. So this is, I hope, last minute. If anybody wants to write down the Zoom ID, 942-1900-5075, and the password Phys319, P is a capital letter. طيب. It's tonight at 7 p.m. طيب. So now let's go back to our business. So we were talking about a uniform circular motion in chapter 5. And remember, in uniform circular motion in chapter 5, we said it's a motion on a circle where you have V is constant, the magnitude of the velocity, which we call speed, is constant. And as a result, we said we will have an acceleration, the magnitude of which this acceleration is V square over R. So it's V square over R. Before I go to the lecture, I have a question on the chat panel. Everyone should answer now. Okay, stop. Okay, I want your answer. If an object is hanging by a rope, write down in the chat panel the normal force. If an object is hanging in the air by a rope, I'm talking about the normal force. Again, if an object, keep answering. Whoever did not answer, everyone should answer this. If an object is hanging in the air by a rope, okay, what is the normal force? I'm talking about the normal force only. I'm not talking about anything else. طيب, and I will draw it. هذه فيها major defect. And I hate if someone make this mistake. If one person make this mistake, I am angry. One person. This is an object of mass M hanging by the ceiling by this rope. What are the forces affecting this object? We said the gravity, right? And what's this? Tension force. Do we have other than these two forces? No. What is the condition? What's 10? What is the condition for a normal force? A surface. I need a surface. If there is no surface, no support, then there is no normal force. Okay? No normal force if there is no surface. So the only forces here affecting this object is a gravity, which we cannot ignore, plus a tension force, which is always directed along the cord and out of the object. هذه نقطة we should خلاص move forward. No surface on an object, surface is not touching the object, means no normal force. إذا نغلط بهذه الأغلاط البسيطة يا شباب كارثة. كارثة. In this situation, these two are equal. Yes. كيف عرفت إنه equal? Because the object is hanging. ما عنده acceleration, right? معلق. So it's not moving. It's hanging in the air. There is a balance. It's not moving upward. It's not moving downward. There is no acceleration. طيب. And I hope nobody make a mistake of normal force of an object hanging in there. Even one person, it bothers me. Even one person, it bothers me. طيب. So we go back. So we said an object in a uniform circular motion of radius r, and either this object can move this way or move this way. We said the velocity at any moment should be the tangent, and it's changing all the time if you decide to move in the counterclockwise direction, but the speed is constant. And we said there is an acceleration always points toward the center, and this acceleration magnitude is v squared over r. Now, in this chapter, in chapter 6, he goes back to this principle, but he said, I taught you about forces, and I taught you that F will equal ma, right? F equals ma. So if an object moving on a uniform circular motion, then acceleration, you know, which is centripetal or radial acceleration, v squared over r. But how about the force? Yes, it's a force that caused the object to be in a centripetal or uniform circular motion. Yani, the direction, notice, of this force should be the same direction of the acceleration. So the acceleration is toward a center, and the force also has to be, the force of pulling, of course, is toward the center. What this force can be? If a car is driving and making circles in a parking lot, what is this force should be? Should be friction. Because the force of a friction between the wheel, the car wheel, and the road makes attraction or makes this car in a uniform circular motion that is pulled toward a center of the circle. That's pulled toward a center of the circle. In this regard, a friction force works as a centripetal force. So this side now is a friction force, which you will see later. It's a mu s Fn. What is Fn? A normal force. But why I selected mu s, not mu k, we'll come to this in this lecture. Although the car is moving, right? But this is the only case where you select for something moving static frictional force. This is the only case. Type. Then here, knowing this, now let's try different situations of objects. So now the new force is called centripetal force, is ma, and the a is v squared over r. Now, if I have a mass, a stone attached to a string, and I'm doing circles, I'm rotating this mass, and I'm doing circles. So here I have a center here a center, this is a rope, and here I have a mass, stone or something, and it's making circles. Because of the rope, the tension force works now as the centripetal force in this situation. And it is out of the object, and it should be toward the center, along the cord, along the rope, or toward the center. It's the same thing. So depending on the situation, the centripetal force, the force that causes pulling toward the center, can be different phases. It can be friction. It can be tension if there is a rope, horizontal object, of course. It can be gravity, as we will see. Gravity, yes, it can be gravity. Let's see how it can be gravity, for example. This is a game, and you know, this is a very interesting game. And people sit on these chairs, either this chair here, or say this chair here. A person, I'll magnify it, A person can sit here, and he goes and experience on this top point and bottom point, he will experience forces. Okay, so let's read the question. As every amusement park fan knows, a Ferris wheel is a ride consisting of seats mounted on a tall ring that rotates around a horizontal axis. Okay, so this is the axis, المحور. When you ride in a Ferris wheel at a constant speed, what are directions of your acceleration? A. Well, if you are at the top here, I expect an acceleration direction will be toward down. So it is negative acceleration. If you are located at the bottom here, then I expect an acceleration to be positive, which is up. So this is negative j hat. Let me select another color. So this is negative j hat acceleration, and this is positive j hat acceleration. So it depends on your location on a Ferris wheel, where you are seated. Like, good. Follow me. Okay. What are the directions of your acceleration and the normal force? Huh? Normal force? Normal force. What we said, normal force needs a surface on the man. So he's sitting, okay? So he's sitting on the chair. So the chair will apply a normal force. Which direction when he's in the up situation? Up. And when he's in the bottom situation, where is the normal force? On the chat panel. Where is the normal force when the person is located at the bottom of the Ferris wheel? Also up. Yes, correct. Also up. This is the reply of the surface, resistance of the surface, always up toward the center. Okay, up toward a center. I'm interested in these two situations, top and bottom. So let's analyze. I need to analyze this. So I will magnify it again. And here is the man again. And here is the man again. طيب. Here he have acceleration, negative acceleration, negative j hat, right? And here he has acceleration, positive j hat. Then different acceleration, whether he is at the top of the Ferris wheel or at the bottom of the Ferris wheel. Now, let's analyze the forces on the man. The man experienced how many forces? Only two forces. Gravity, ما في tension. He's seated on a chair. Gravity and a normal force. So the force of gravity when he is in the top, down, and the normal force is up. So F normal is up, and force of gravity down. When he is located here at the bottom, also force of gravity down, and the normal force is up. Same thing. I'm talking about the forces, not accelerations. I'm talking about forces, not accelerations. الآن, can you write the equation, Newton's equation, in this situation, F equal ma? Let's write it at the top here, this situation. How can I write it? Fn, which is positive, minus mg, which is negative, and the mg is down, negative j hat. And now this side, we said the acceleration is negative. So it is minus m v square over r. Why? Because it's centripetal acceleration. Yeah, صح. مظبوط. Why negative sign? Because it depends his location on the circle. He's at the top, so he's pulled toward the center with acceleration toward the center. Now, let's write the same equation for this situation. Same thing, Fn is positive, up. This is the reply of the surface, minus mg, down, gravity always down, equals what? Now the acceleration is positive, so it is plus mv square over r. Notice that لو أطلب منك أقول لك what is the normal force in the up? What it should be? I move the minus to the other side. So it will be what? Plus mg minus lv square over r. Is this normal force big or small when he's at the top? It's small. Why? I subtract two terms. I subtract mg minus mv square over r. So it's small. Now, in this situation, what is Fn at the bottom? يلا ساعدني. I move this minus mg to the other side. So it's plus mg. And I add to it another term. So it is v square over r. طبعا here I made a typo. Here should be m, of course. Now what? So which normal force is greater? When the man is located at the top of the Ferris wheel or at the bottom of the Ferris wheel? At the top or at the bottom of the Ferris wheel? At the bottom of the Ferris wheel. Okay? So on the left side of the equation F equal ma, we write forces. On the right side, we write acceleration. If the acceleration was centripetal, which is an object moving on a circle, it will be v square over r. Depends on the direction of the acceleration. I can put a negative sign, a positive sign, a positive I hat, a negative I hat, or anywhere I would like, because I understand the principle. And let's answer this. He said, tell me the equation the normal force in the upward or in the downward situation. We solve them. Part C, how does the magnitude of the acceleration at the highest point compare with that of the acceleration at the bottom point? Okay? يعني الاكسلريشن اللي هو الترم v square over r, how does the magnitude of the acceleration, the magnitude are they equal? They should be equal. Okay, they must be equal. I'm talking about only the acceleration. The acceleration, it has only one law, v square over r. So the acceleration at the top and the bottom should be the same. How do the magnitude of the normal force compare? لا. The magnitude of the normal force at the bottom is big, and here the magnitude is small. So at the normal force is greater in the bottom than in the top. Okay, anybody has a question here? Questions invited. Anybody has a question? Good. Now everybody understands this. This is good. Let's take more examples. It's all examples. It's all examples. Let's take this. So this is a game used usually in the circus, where a person riding a bicycle, he's making circles, and sometimes when he's located upside down, شوف, where is the situation here? Upside down, he doesn't fall. طبعا it used to entertain people, and people wonder why this can happen. He's upside down, but he doesn't fall. They don't know physics. They don't know physics. We need to analyze his motion and see what is he doing so that he doesn't fall down. What does he do? And by the way, it's the same thing when you go on a ride. I don't know what's called here in the amusement parks, where you are totally in a cart and you are totally upside down on a track, ومقلوب totally, and you don't fall, and the cart doesn't fall. There should be something that caused this. So let us see. Okay, in a 1901 circus performance, Allo Diavolo, his name, introduced the stunt of riding a bicycle in a loop-the-loop. Loop-the-loop means he making complete loop. A radius of this loop is 2.7 meters. So the radius is how much? 2.7. What is the least speed of the Diavolo and his bicycle could have at the top of the loop to remain in contact? ركز معايا كويس. ويقول لك, this person, he will fall, for example, if he stop at the top, he will fall. But it looks like his speed plays a factor in keeping him in contact. What's another word for in contact? Normal force, the threshold becomes 0. If the normal force becomes 0, he lost contact. Again, when the man is in this situation, if he is not in contact with the surface, this is the threshold when the normal force becomes 0. Normal force is 0 when you don't have contact with the surface. So he's asking you, what is the least speed this person could have so that his normal force will be on the threshold of being 0. So let's see. So first of all, let's analyze his motion when he is on top. When he's here, what are the forces affecting the man? I have a gravity and I have normal force. So I have F gravity and I have F normal. صح؟ هي F normal down. Why? Because here is the surface. أنا صرت أتضايق من النورمال فورس. المعلومة اللي وصلتني الناس لسه ما تفهمش النورمال فورس. A normal force is down and a gravitational force is also down. Why normal force is down? Because this is the surface. This is the surface. We said it's the resistance of the surface. We'll push him down. We gave an example like this in the class. We said if I have a mass against the ceiling, the normal force will be down. So what is the analysis of these forces now? I need to write a Newton's equation. So Newton's equation said the left side is reserved for the forces. Both forces are negative. A normal force is negative, while a gravitational force is negative. This side is for the forces. This side for the acceleration. You see now why we put a negative acceleration? Because when he's at the top, the acceleration should be toward the center. So it should be negative. Yani acceleration always like this. So it should be negative acceleration. Okay, good. Now everything is negative. By the way, when everything is negative, you can multiply by -1. So everything becomes positive. Yeah, you agree with me, huh? If all the terms of the equation, left side and right side math, negative, You can multiply by any constant. You don't change anything in the equation. Or you can basically move these to this side and move this to the left side. It's the same thing. It's everything is positive. طب, after everything is positive, then when the man will fall, when in this term, a normal force, this term is equal to 0. You agree with me? The man will fall. He will lose contact when the normal force is equal to 0. So this is the threshold. So I calculated velocity of the bicycle and the man at normal force equals 0, and any velocity less than this, the man will fall. Yani if he has a cruise control on his bicycle, assuming theoretically he has a cruise control on his bicycle, then the man, if he can fix his speed to be, طبعا, when you supply here 0, mass cancels. It's independent of his mass, or it has nothing to do with his mass. Then take the equation will become v square root of g r. Yani it only depends on the radius of the loop. If the radius of the loop is big, so he needs big velocity. When we plug the numbers given to us in the question, the speed now 5.1. Yani if he has a cruise control and he keep his speed 5.1 or more than 5.1, he will not fall. At 5.1 exactly and less, he will fall. Why? Because at 5.1, the normal force is equal to 0. Less, of course, less means the normal force is totally 0. So the trick in this game is that the man has something like a cruise control, and he's trained to keep his velocity higher than 5.1, even 5.11. But notice an important here conclusion. It does not depend on his mass. Again, it does not depend on his mass. Why it does not depend on his mass? Because we can cancel the mass term from both sides. If his mass was 100 kilograms or 50 kilograms, it doesn't matter. It is independent of his mass. It depends on his velocity and the radius of that loop. Okay? Right, let's see. Anybody has a question? Let's see participant. Anybody has a question? Raise your hand. Let's see the chat panel. Maybe we have questions there. Can you repeat why Fn equals 0? طيب. السؤال يقول what is the least speed so that he remain in contact? What is the word in contact between him and the ceiling of the loop? Means there is normal force. So he said, if I want to calculate when he will fall down, it is the threshold when the normal force equals 0. It is the threshold when the normal force equals 0. When the normal force equals 0, the man will fall. لأنه he's not in contact anymore. You agree with me? احنا مش قلنا شرط condition for the normal force. There is a surface. If there is no surface, then the man will fall. He's not in contact. Okay? It does not depend on the momentum. We did not study momentum yet. This will be chapter 9. Don't bring momentum. Momentum related to velocity or speed. So it is. But don't bring momentum now. We have nothing to do with momentum. It has nothing to do with momentum. Okay? Right. So from here, we can conclude the following. We can say, if the man velocity 5.1 or less, he will fall. If the man velocity by his cruise control 5.11 and more, he will not fall. A threshold is when the normal force equal to 0. Let's see another example. We have many examples. Here I told you, when you are in a uniform circular motion on a flat floor, here imagine you have a car or a bicycle, same example. طبعا هذا old exam question, but it is repeated 100 times. So I want to warn you from this question. Here is a man on a bicycle or a car. It's the same principle. You are riding a bicycle, riding a car. طبعا this is horizontal street. Yeah, you drive on a parking lot, ساحة كده مستوية, flat, right? So if you successfully making circles with your car, so there is a friction, definitely. You're not attached by a rope. Your car is not attached by a rope to the center of the circle, and you don't have any force toward the center. So the only force is the friction force. If the friction force in this situation, I put it in red, is a static frictional force, although the object is doing circles and is moving. Why static? Because for the wheel, if somebody is standing at the center, he will not see the wheel here of the car rotating. He will see it stand still. So relative to him at the center, the wheel of the car is not moving. If the car is moving toward him or away from him, then you have to use kinetic frictional force. But because it is not moving relative to him, so we'll use a static frictional force. طب هذا الexample when it comes said, find the smallest radius of a circular flat horizontal track. So this is the same thing. Find the smallest radius, which a bicyclist travel if his speed is 30 kilometers. He gave you the speed, هذه V. And the coefficient he gave you mu S, and he gave you mu K. طبعا you wonder why he gave me mu S and mu K, although I have to use mu S, because he wants to make sure you understand. Some students, they make the mistake and they say the bicycle or the car in a uniform circular motion, it's moving, so I have to use mu K. That's a mistake. And I put it in red here so that everybody doesn't make a mistake. واللي يغلط فيها يكون إنسان ما يبغى هذه العلامة. يسألوك السؤال وما تجيب معناه أنت you don't want this mark. Okay? So now, how to solve this question? We solve in a usual way. We said, the equation of the force is the friction force. And where is the direction of the friction force? If this is the origin, where is the direction when he's here? Is toward the negative. So it is minus a force toward the negative. This force is the centripetal force. So it is toward the center. We said the force and the acceleration are in the same direction. So it is negative. And on this side, the acceleration is toward the center. So it's also negative. A negative sign then cancels out with a negative sign. But this is Fs. This is not Fk again. This is Fs. And what is Fs in this situation? It's mu S بالnormal. لكن for the bicyclist here, what is the normal force? He has two forces, mg down, one normal. So normal force is guaranteed is equal to mg. If, for example, there is another force here, a normal force will be different. I have to calculate it. I have to calculate the normal force because I have to analyze this force into two components. Then the normal force will differ. But in this situation, I don't have additional force. So only I have a normal force up and the gravitational force down. So normal force equals mg. طبعا واحد راح يقول لي why acceleration zero? Because he's at the surface. He's not drilling down and he's not flying in the air. He's at the surface. So there is no y acceleration. There is no y acceleration here. There is only horizontal acceleration toward the center, centripetal acceleration. So mu s mg, minus signs cancels out. Mu s mass, notice it does not depend on the mass here. So r, you arrange the equation v squared over mu sg. Substitute 8.33 meters per second or 30 kilometers. When you substitute, if the radius of the bicyclist he's making is 22 or more, he will be able to make circles with this speed. With this speed, which is high speed, 30 kilometers per hour for a bicyclist. If his speed is higher than this, he will fall. He will not be able to do circles, horizontal circles. This is an important old exam question. Type. Now let's take an example in the book that I find extremely also necessary. Let's see. In the figure, a car is driven at constant speed over a circular hill. يعني هذه car, and you have a hill, تلة, and you have a valley. So the car will make a hill and then go down in a valley, okay? As if somebody looking on the side, okay? طيب. Let's take a pencil here. At the top of the hill, the normal force on the driver, so there is a driver seated here. He said the normal force Fn is zero. يعني هذا طبعا احنا عارفين there is surface, but this is in the question. He said assume a normal force is zero. ما واحد يقول لي لا ما انت قلت لنا اذا في surface في normal force. صح. But if he said assume إنه الرجال he feels himself flying, he doesn't feel the chair, so the normal force is zero. The driver's mass is given 70 kilogram. What is the magnitude of the normal force on the driver from the seat at the bottom here? إذن هنا الرجال وصل here. He said, give me, if the normal force here is zero, tell me what's the normal force here at the bottom. Okay, so and I take the same thing I did for the Diavolo. What I do? I will take the equation. What is the equation when he is at the top? What's the equation when the man is on the top? the equation, I have F normal, هنعملها سوا, F normal, which is positive, theoretically, minus mg. Where is the acceleration? If this is a circle here, where is the acceleration? Down. So it's negative. So it is minus mv square over r. This is at the top, right? طبعا هو يقول لك الآن this F normal is equal to 0. This F normal is equal to 0. Now the minus cancels with the minus. The mass of the man cancels with the mass of the man. From here, I know that R, I can get G, or G will equal V square over R. This information I need. This information I need. It relates speed with the radius. هذا speed with طبعا G doesn't change 9.8, but it relates his speed with the radius. Now, he doesn't want, he wants a normal force here. So normal force here is made of what? F normal up with gravitational force down. And where is the direction of the acceleration? Up. So let's show you. Okay, let me just remove this. Okay, so here, Fn mg plus v square over r, but the Fn is equal to, what's this? Okay, so here in this situation, if, at the top, Fn is equal to 0, so this is what we derive. El v square is gr. This is what we derived, okay? Because here I substitute Fn equal 0. Then v square equal gr. Now at the top, here, let me bring a pencil. At the bottom of the valley, two forces means Fn minus mg. And what is the acceleration? The acceleration should be positive or negative? It should be positive. Why? Because toward the center land, this is the circle. So it is a plus m v square over r. Now, I know LV from the previous thing. I got for V square, I got something. It is GR. So I can substitute it. When you substitute it, you can get a normal force. Why? Because this mg, take it to the other side. You know the mass, you know the g, and the only unknown is V square. And V square, we have an equation for it from the first part. Substitute, and you can get a normal force on the man from his seat when he is at the bottom of the valley. Okay, anybody has a question? طيب, chat. Can you repeat how we determine the static in the last example? Yes, we said if a car or a bicycle on a horizontal flat surface, of course, that's the only way you drive a car or a bicycle, then you're doing circles, the only force is a friction force. And the nature of this friction force is static, not kinetic. And that's the only case where you have something moving and you have to substitute static frictional force. The reason? Because relative to a person at the center of the circle, he does not see the car moving. He will see the wheel stand still. Okay? طيب, what about R? R is given. R خلاص, we don't need R in this example. R, we don't need it in this example. لأنه V square over R, all of it here, V square over R, all of it is what? Is G. I don't need to know V. So all this, I replace it with what? With G. So 2mg. Yeah, the answer is 2mg. And 2mg, 2 by his mass, 70, by the G, which is 9.8. So you can get the normal force. So normal force on the car at the top is 0. The normal force on the car at the bottom is equal to 1,370 newtons. Right. Let's take another example. This is old exam question. A 2-kilogram ball is fastened to a string by a 1 meter length and set into vertical circular motion. So somebody attached a stone وhad a vertical motion. This is not horizontal. مش يعني vertical, which means it's vertical. ارتفاع. It's not horizontal circles. It's not horizontal circles. You know in English what's the mean by vertical, horizontal. This is horizontal and this is vertical. So vertical, there is possibility for a gravity, yes, because it's vertical. So here, somebody fastened a 2-kilogram ball to a string of 1 meter length and set into vertical circular motion. Vertical circular motion. find the magnitude of the tension when the ball is at the bottom. طب when the ball, this ball at the bottom, what are the forces affecting it? يلا عندي ال mg والtension. Is there any normal force? Write down in the chat panel. What's the normal force in this example? What's the normal force? Of course, zero. There is no surface. The mass is attached by a string and it's doing in air. It's doing circles, vertical circles. So there is no normal force. It's not like the car on the valley, on the top of the valley or the mountain or the hill. So there is no normal force. So the only two forces, tension up و mg down. So كيف تصير الإيكويشن؟ plus t أنا أتكلم هنا at the bottom minus mg. And where is the direction of the acceleration? Is the acceleration should be what? Positive or negative? When he's at the bottom, positive. So it is m v square over r. So what's the answer now? T هو يبغى T هذه is equal what? mg minus m v square over r. Now what's the m? 2 kilogram. The g 9.8. What's the m? هذه not negative, هذه positive, right? Sorry, why we said this is negative? Why would the mass is 2 kilogram? Well, v is given 7.74. Well, r is the radius is 1 meter. The radius is the length of the string itself. When you substitute, يعني substitute 2, 7.7 square over 1, you get what? 139 Newton. Is it difficult? It's not difficult. Just have to know. طب assume I will make an addition. I will make an addition. When the ball is here, وهذا الstring, what are the forces affecting the ball? Here, the ball is, there is tension force down, وفي gravity also down. So minus, and the other side should be negative acceleration or positive? Should be negative. So it is minus m v square over r. طبعا هذه all of it minus, so you can do like this, plus, plus, plus. Just like the diavolve, yes. Is it difficult? It's difficult. It's not difficult. You know how to write a force equation only, and then you can solve. Actually, it's very easy. If you understand, it's very easy. If you don't understand, it will look really difficult to you. If you memorize, it will look really difficult. Clear. ممتاز ممتاز ممتاز. Good. طيب الآن we can start a review of some questions. The speed of an object, just give me one second. Just give me 1 second. Let me just magnify this. طيب. The speed of an object is given by v equals square root of p over rho. This is a question on chapter 1. Now we are doing review of chapters 1 to 4. This will be the topic of also the next lecture. So the next lecture will be the reviews. Remember the questions I posted? Review chapter 1 to 4. Now we are discussing them. I told you to start solving them. So when we discuss them, the benefit is maximum. The speed of an object is given. So what does this mean, this speed? It means L over T. With dimensional analysis, it's length per time, meter per second. And what is this? This is density. And what's the unit of density? It is kilogram per meter cube. So it should be m over L cube. You agree with me? Density. And what is this? He said, give me the dimensions of B. So I can do a cross multiplication. So I'll do square both sides, this equation. So V square B over density. I rearrange. Now, this B, I don't know. So what is the density? Kilogram per meter cube or mass per length cube time. صح؟ طبعا square. So length square, T square. So length square cancels with L cube, what T is given. So the answer is this. في أسهل من كده? Just easier than the examples we solved. Anybody has a question on this? Anybody has a question in this? Anybody has a question? easy. طيب ممتاز. ممتاز. Good. Let's take more examples. Okay. Let's take more examples. The speed time relation of a moving particle is given by v half at plus b. It should be what? This side. L over, this one should be what? L over t. It's a speed. Length over time. Now each term, I know if this is a speed and this is a correct equation as he said, so this has to be what? L over t. All of it. And all this term will also have to be what? L over t. Yeah, that's the meaning of dimension analysis. All the terms, they should have the same dimensions. Where v is the speed, t is the time, and a, b, c are constants. The dimensional formula of the constant a, b, and c. Tell me the dimensions of the constant a and b and c. The easiest one, in my opinion, is a. Why a? Because I know a here is, this is, I take this side, a. So let's take this side. So L over T and take the first term, هذا الترم. What's the dimension of this term? We said the half has no dimension. L A, leave it as A. What T is what? Big T. So now what's the dimension of A? A will equal L over T square. We're done with A. Easy to do A first. هو يبغى A, B, C. Now you can look at the answers. L over T square. Whoa, that's the only one. By the way, if you are in the exam, no need to do B and C. خلاص. This is the only answer that has A L over T square. L over T square. That's the only answer. But for the sake of clarity, let's do B and C. How to solve now B and C? How to solve B and C? Now, this B, this T is added to a term T. So it should have, you cannot add two things if they don't have the same dimension. So the C has to have the same dimension as time. So C should have the same dimension at time. So it's T, direct. Now, once you know this is T, what should be the dimension of B? The dimension of B should be L. Why? Because all this term has to be L over T. يعني do it step by step. You do it step by step. Why we did not start with B? If I attempt to solve B without knowing C, it will be, maybe it's difficult for me. Okay? Right. Another example. I have, a few questions. This is the most difficult, but also it can be solved. It's not that difficult. So this is a magnitude of a force applied on an object is given by a relation. By the way, we know the dimension of the force. So he said the force dimension is F, constant K, density X, U to power Y, and T to power Z, where K is dimensionless. Oh, he said this is dimensionless. This has no dimension, يعني one, خلاص. Rho is the density. Okay, he tells me what all this. V is speed. What T is time. Yeah, okay. So, by the way, what's the dimension of the force? And I know that the force is MA. So it should be M meter, M, big M, and A, L over T square. So this is the left side dimension. Why? لأنه F equals MA by default. The force, Newton's second law, equals MA. What's the dimension of the mass? Big M. And what's the dimension of the acceleration? L over T square, or LT minus 2. It's the same thing. Now this K is dimensionless, so ignore it. 1. Here is density. What's the dimension of the density? It's mass over volume. Mass ml over a cube to power x. I need the powers. He wants me to find the powers. So leave it for now. And what is the dimension of this velocity or speed? Is L over T or LT minus 1. And what's the power? Y. I need to know Y. And T to power Z. Yeah, because what's the dimension of the time? Is T to power Z. I don't know X. I don't know Y. I don't know Z. Knowing the left side and the right side, I should find X and Y and Z. How? I just collect terms together. So the mass here is the power of the mass is how much? Is 1. The mass here has only 1 power because of this X. So which is X? So directly X has to be 1. From the left side, the mass has the power 1. And from the right side, the mass only has, when I open it up, has power X. So I know X has to be 1, or otherwise the equation is wrong. Now, If I take this L, when I collect the terms for L, I find that L minus 3x plus y. And what's the power of L? Is 1. So 1 is equal minus 3x plus y. But because I know x is equal 1 from the first part, so y will be 4. We're almost there. So x is 1, and y is 4. By the way, up to, you need to solve because E also has an answer different. So now for the t, what's the power here is minus 2. So minus 2 equals what? Minus 4 plus z. Just collecting the terms. So when you add, when you solve, z will equal to 2. So the answers, x and y, z powers, can be found easily by comparing the two terms. Let's see if I have a question. Anybody has a question? Let me see the chat panel. Yes, good. Okay, good. People are ready and they answer. Type. This is chapter 2. We have 1 minute. So inshallah, we continue next time, ya shabab. We have to stop here because chapter 2 has a good start. We have 1 minute. I just, before you go, for the benefit of anybody who would like to attend, again, last, if you want to take a shot, the Zoom ID 94219005075 and the password Fizz319. Tonight at 7 p.m. if you're interested to attend. Inshallah, we meet next time on